Chapter 5, Part 2 of Airplane Flying Handbook, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jennifer Dorr. Airplane Flying Handbook, Volume 1 by the Federal Aviation Administration. Takeoffs and Departure Climbs, Part 2. Ground effect on takeoff. Ground effect is a condition of improved performance encountered when the airplane is operating very close to the ground. Ground effect can be detected and measured up to an altitude equal to one wingspan above the surface. See Figure 5-6. However, ground effect is most significant when the airplane, especially a low-wing airplane, is maintaining a constant attitude at low airspeed at low altitude. For example, during takeoff, when the airplane lifts off and accelerates to climb speed, and during the landing flare before touchdown. When the wing is under the influence of ground effect, there is a reduction in upwash, downwash, and wingtip vortices. As a result of the reduced wingtip vortices, induced drag is reduced. When the wing is at a height equal to 1/4 the span, the reduction in induced drag is about 25%. And when the wing is at a height equal to 1/10 the span, the reduction in induced drag is about 50%. At high speeds where parasite drag dominates, induced drag is a small part of the total drag. Consequently, the effects of ground effect are of greater concern during takeoff and landing. On takeoff, the takeoff roll, liftoff, and the beginning of the initial climb are accomplished in the ground effect area. The ground effect causes local increases in static pressure, which cause the airspeed indicator and altimeter to indicate slightly less than they should, and usually results in the vertical speed indicator indicating a descent. As the airplane lifts off and climbs out of the ground effect area, however, the following will occur. The airplane will require an increase in angle of attack to maintain the same lift coefficient. The airplane will experience an increase in the induced drag and thrust required. The airplane will experience a pitch-up tendency and will require less elevator travel because of an increase in downwash at the horizontal tail. The airplane will experience a reduction in static source pressure as it leaves the ground effect area and a corresponding increase in indicated airspeed. Due to the reduced drag in ground effect, the airplane may seem to be able to take off below the recommended airspeed. However, as the airplane rises out of ground effect with an insufficient airspeed, initial climb performance may prove to be marginal because of the increased drag. Under conditions of high density altitude, high temperature, and/or maximum gross weight, the airplane may be able to become airborne at an insufficient airspeed, but unable to climb out of ground effect. Consequently, the airplane may not be able to clear obstructions or may settle back on the runway. The point to remember is that additional power is required to compensate for increases in drag that occur as an airplane leaves ground effect, but during an initial climb, the engine is already developing maximum power. The only alternative is to lower pitch attitude to gain additional airspeed, which will result in inevitable altitude loss. Therefore, under marginal conditions, it is important that the airplane takes off at the recommended speed that will provide adequate initial climb performance. Ground effect is important to normal flight operations. If the runway is long enough, or if no obstacles exist, ground effect can be used to an advantage by using the reduced drag to improve initial acceleration. Additionally, the procedure for takeoff from unsatisfactory surfaces is to take as much weight on the wings as possible during the ground run and to lift off with the aid of ground effect before true flying speed is attained. It is then necessary to reduce the angle of attack to attain normal airspeed before attempting to fly away from the ground effect area. Short field takeoff and maximum performance climb. Takeoffs and climbs from fields where the takeoff area is short or the available takeoff area is restricted by obstructions require that the pilot operate the airplane at the limit of its takeoff performance capabilities. To depart from such an area safely, the pilot must exercise positive and precise control of airplane attitude and airspeed so that takeoff and climb performance results in the shortest ground roll and the steepest angle of climb. See Figure 5-7. The achieved result should be consistent with the performance section of the FAA-approved Airplane Flight Manual and/or Pilot's Operating Handbook, AFM-POH. In all cases, the power setting, flap setting, airspeed, and procedures prescribed by the airplane's manufacturer should be followed. In order to accomplish a maximum performance takeoff safely, the pilot must have adequate knowledge in the use and effectiveness of the best angle of climb speed, Vx, and the best rate of climb speed, Vy, for the specific make and model of airplane being flown. The speed for Vx is that which will result in the greatest gain in altitude for a given distance over the ground. It is usually slightly less than Vy, which provides the greatest gain in altitude per unit of time. The specific speeds to be used for a given airplane are stated in the FAA-approved AFM-POH. It should be emphasized that in some airplanes, a deviation of 5 knots from the recommended speed will result in a significant reduction in climb performance. Therefore, precise control of airspeed has an important bearing on the successful execution as well as the safety of the maneuver. Takeoff roll. Taking off from a short field requires the takeoff to be started from the very beginning of the takeoff area. At this point, the airplane is aligned with the intended takeoff path. If the airplane manufacturer recommends the use of flaps, they should be extended the proper amount before starting the takeoff roll. This permits the pilot to give full attention to the proper technique and the airplane's performance throughout the takeoff. Some authorities prefer to hold the brakes until the maximum obtainable engine RPM is achieved before allowing the airplane to begin its takeoff run. However, it has not been established that this procedure will result in a shorter takeoff run in all light single-engine airplanes. Takeoff power should be applied smoothly and continuously without hesitation to accelerate the airplane as rapidly as possible. The airplane should be allowed to roll with its full weight on the main wheels and accelerated to the liftoff speed. As the takeoff roll progresses, the airplane's pitch attitude and angle of attack should be adjusted to that which results in the minimum amount of drag and the quickest acceleration. In nosewheel-type airplanes, this will involve little use of the elevator control, since the airplane is already in a low-drag attitude. Liftoff. Approaching best angle of climb speed, Vx, the airplane should be smoothly and firmly lifted off or rotated by applying back elevator pressure to an attitude that will result in the best angle of climb airspeed, Vx. Since the airplane will accelerate more rapidly after liftoff, additional back elevator pressure becomes necessary to hold a constant speed. After becoming airborne, a wing's level climb should be maintained at Vx until obstacles have been cleared or, if no obstacles are involved, until an altitude of at least 50 feet above the takeoff surface is attained. Thereafter, the pitch attitude may be lowered slightly and the climb continued at best rate of climb speed, Vy, until reaching a safe maneuvering altitude. Remember that an attempt to pull the airplane off the ground prematurely or to climb too steeply may cause the airplane to settle back to the runway or into the obstacles. Even if the airplane remains airborne, the initial climb will remain flat and climb performance, obstacle clearance, ability seriously degraded until best angle of climb airspeed, Vx, is achieved. See Figure 5-8. The objective is to rotate to the appropriate pitch attitude at or near best angle of climb airspeed. It should be remembered, however, that some airplanes will have a natural tendency to lift off well before reaching Vx. In these airplanes, it may be necessary to allow the airplane to lift off in ground effect and then reduce pitch attitude to level until the airplane accelerates to best angle of climb airspeed with the wheels just clear of the runway surface. This method is preferable to forcing the airplane to remain on the ground with forward elevator pressure until best angle of climb speed is attained. Holding the airplane on the ground unnecessarily puts excessive pressure on the nose wheel, may result in wheelbarrowing, and will hinder both acceleration and overall airplane performance. Initial climb. On short field takeoffs, The landing gear and flaps should remain in takeoff position until clear of obstacles, or as recommended by the manufacturer, and VY has been established. It is generally unwise for the pilot to be looking in the cockpit or reaching for landing gear and flap controls until obstacle clearance is assured. When the airplane is stabilized at VY, the gear, if equipped, and then the flaps should be retracted. It is usually advisable to raise the flaps in increments to avoid sudden loss of lift and settling of the airplane. Next, reduce the power to the normal climb setting, or as recommended by the airplane manufacturer. Common errors in the performance of short-field takeoffs and maximum performance climbs are: failure to adequately clear the area, failure to utilize all available runway takeoff area, failure to have the airplane properly trimmed prior to takeoff, premature liftoff resulting in high drag, holding the airplane on the ground unnecessarily with excessive forward elevator pressure, inadequate rotation resulting in excessive speed after liftoff, inability to maintain best angle of climb airspeed, fixation on the airspeed indicator during initial climb, premature retraction of landing gear and/or wing flaps. Soft, rough field takeoff and climb. Takeoffs and climbs from soft fields require the use of operational techniques for getting the airplane airborne as quickly as possible to eliminate the drag caused by tall grass, soft sand, mud, and snow, and may or may not require climbing over an obstacle. The technique makes judicious use of ground effect and requires a feel for the airplane and fine control touch. These same techniques are also useful on a rough field, where it is advisable to get the airplane off the ground as soon as possible to avoid damaging the landing gear. Soft surfaces or long, wet grass usually reduces the airplane's acceleration during the takeoff roll so much that adequate takeoff speed might not be attained if normal takeoff techniques were employed. It should be emphasized that the correct takeoff procedure for soft fields is quite different from that appropriate for short fields with firm, smooth surfaces. To minimize the hazards associated with takeoffs from soft or rough fields, support of the airplane's weight must be transferred as rapidly as possible from the wheels to the wings as the takeoff roll proceeds. Establishing and maintaining a relatively high angle of attack or nose-high pitch attitude as early as possible does this. Wing flaps may be lowered prior to starting the takeoff, if recommended by the manufacturer, to provide additional lift and to transfer the airplane's weight from the wheels to the wings as early as possible. Stopping on a soft surface such as mud or snow might bog the airplane down. Therefore, it should be kept in continuous motion with sufficient power while lining up for the takeoff roll. Takeoff roll. As the airplane is aligned with the takeoff path, takeoff power is applied smoothly and as rapidly as the power plant will accept it without faltering. As the airplane accelerates, enough back elevator pressure should be applied to establish a positive angle of attack and to reduce the weight supported by the nose wheel. When the airplane is held at a nose-high attitude throughout the takeoff run, the wings will, as speed increases and lift develops, progressively relieve the wheels of more and more of the airplane's weight, thereby minimizing the drag caused by surface irregularities or adhesion. If this attitude is accurately maintained, the airplane will virtually fly itself off the ground, becoming airborne at airspeed slower than a safe climb speed because of ground effect. See Figure 5-9. After becoming airborne, the nose should be lowered very gently with the wheels clear of the surface to allow the airplane to accelerate to VY or VX if obstacles must be cleared. Extreme care must be exercised immediately after the airplane becomes airborne and while it accelerates to avoid settling back onto the surface. An attempt to climb prematurely or too steeply may cause the airplane to settle back to the surface as a result of losing the benefit of ground effect. An attempt to climb out of ground effect before sufficient climb airspeed is attained may result in the airplane being unable to climb further as the ground effect area is transited, even with full power. Therefore, it is essential that the airplane remain in ground effect until at least VX is reached. This requires feel for the airplane and a very fine control touch in order to avoid over-controlling the elevator as required control pressures change with airplane acceleration. Initial climb. After a positive rate of climb is established and the airplane is accelerated to Vy, retract the landing gear and flaps if equipped. If departing from an airstrip with wet snow or slush on the takeoff surface, the gear should not be retracted immediately. This allows for any wet snow or slush to be air-dried. In the event an obstacle must be cleared after a soft field takeoff, the climb-out is performed at Vx until the obstacle has been cleared. After reaching this point, the pitch attitude is adjusted to Vy and the gear and flaps are retracted. The power may then be reduced to the normal climb setting. Common errors in the performance of soft, rough field takeoff and climbs are: failure to adequately clear the area, insufficient back elevator pressure during initial takeoff roll resulting in an inadequate angle of attack, failure to cross-check engine instruments for indications of proper operation after applying power, poor directional control, climbing too steeply after liftoff, abrupt and/or excessive elevator control while attempting to level off and accelerate after liftoff, allowing the airplane to mush or settle resulting in an inadvertent touchdown after liftoff, attempting to climb out of ground effect area before attaining sufficient climb speed, failure to anticipate an increase in pitch attitude as the airplane climbs out of ground effect. Rejected takeoff, engine failure. Emergency or abnormal situations can occur during a takeoff that will require a pilot to reject the takeoff while still on the runway. Circumstances such as a malfunctioning power plant, inadequate acceleration, runway incursion, or air traffic conflict may be reasons for a rejected takeoff. Prior to takeoff, the pilot should have in mind a point along the runway at which the airplane should be airborne. If that point is reached and the airplane is not airborne, immediate action should be taken to discontinue the takeoff. Properly planned and executed, chances are excellent the airplane can be stopped on the remaining runway without using extraordinary measures, such as excessive braking that may result in loss of directional control, airplane damage, and/or personal injury. In the event a takeoff is rejected, the power should be reduced to idle and maximum braking applied while maintaining directional control. If it is necessary to shut down the engine due to a fire, the mixture control should be brought to the idle cutoff position and the magnetos turned off. In all cases, the manufacturer's emergency procedure should be followed. What characterizes all power loss or engine failure occurrences after liftoff is urgency. In most instances, the pilot has only a few seconds after an engine failure to decide what course of action to take and to execute it. Unless prepared in advance to make the proper decision, there is an excellent chance the pilot will make a poor decision, or make no decision at all and allow events to rule. In the event of an engine failure on initial climb-out, the pilot's first responsibility is to maintain aircraft control. At a climb pitch attitude without power, the airplane will be at a near stalling angle of attack. At the same time, the pilot may still be holding right rudder. It is essential the pilot immediately lower the pitch attitude to prevent a stall and possible spin. The pilot should establish a controlled glide toward a plausible landing area, preferably straight ahead on the remaining runway. Noise abatement. Aircraft noise problems have become a major concern at many airports throughout the country. Many local communities have pressured airports into developing specific operational procedures that will help limit aircraft noise while operating over nearby areas. For years now, the FAA, airport managers, aircraft operators, pilots, and special interest groups have been working together to minimize aircraft noise for nearby sensitive areas. As a result, noise abatement procedures have been developed for many of these airports that include standardized profiles and procedures to achieve these lower noise goals. Airports that have noise abatement procedures provide information to pilots, operators, air carriers, air traffic facilities, and other special groups that are applicable to their airport. These procedures are available to the aviation community by various means. Most of this information comes from the Airport Facility Directory, local and regional publications, printed handouts, operator bulletin boards, safety briefings, and local air traffic facilities. At airports that use noise abatement procedures, reminder signs may be installed at the taxiway hold positions for applicable runways. These are to remind pilots to use and comply with noise abatement procedures on departure. Pilots who are not familiar with these procedures should ask the tower or air traffic facility for the recommended procedures. In any case, pilots should be considerate of the surrounding community while operating their airplane to and from such an airport. This includes operating as quietly yet safely as possible. End of Takeoffs and Departure Climbs, Part 2.